So my name is Marina, and I'm going to deliver a talk about serverless and React. And before, I really want to start from my inspiration about it. About a year ago, I started looking into something behind the front end. That was my day job. I just did some deployment, a little bit of backend, and it appears that serverless is awesome technology. Like serverless computation, database, everything's so cool that abstracts complexity from front-end people, and that makes us to really build things without thinking too much about what is going on there. And on my opinion, that time, and actually right now, I think it's really underestimated by front-end community. And I'm not the only one here, you know. My first version of this talk was around a year ago. That was kind of a crappy one, but that one beta, I promise. And just before this version, like a day before, Chris Coyer, actually, do you know this guy? Do you know who's Chris Coyer? Oh yeah, that's, for those who doesn't know, he is behind, he behind the CodePen, CSS tricks and such things. So he tweeted this, and that's exactly what I'm thinking. Like, we need to get more attention into this. Of course, he did much better job than I am. He put a lot of materials in here, a lot of useful links. What I do, I will just do fun, easy demo for you to just show that things is not that scary and it's worth to try it out. But you know, let me start from proper introduction. I'm sorry, I'm just walking here saying hello, Marina. My name is Marina, and just jump into the talk. I am solution architect in EPAM. And my day job is basically jumping around the projects, doing some funny stuff that I really enjoy. So I'm not going to talk about my projects, I just talk what I'm doing, like with what technologies I work, because it will affect what I'm going to talk after it. So that's AWS at my day job, and all the serverless I'm going to do is going to be on AWS. Also front end, I like it a lot, but my day job mostly with React and React Native. Also, because I am a solution architect, I do a lot of documentation that's boring. Let's skip it. And just a little bit icebreaker, you're so quiet. 3 fun facts about me. I have a dog. I really like everything about spaceship. I'm not that much into it to understand what is going on there and like have a meaningful conversation about it. But if somebody talk about it, I just get shivering under my skin. That's honestly, that's so cool. And I really want to go to Japan, and one day we'll do this, just buy tickets, but not today. Next time, honestly. And then let's go back to the business. So what I'm going to do today, as I said, that's going to be a demo, and basically you're all right now in this huge code review. And to make it even more fun, I decided to do it like a novel. So that's going to be part 1 of exposition, then going to be main story, and we will finish with resolution here. Let's start with exposition. Unfortunately, if you want to do serverless, just having cloud function, cloud computation is not enough. You need to use a bit more services, and I'm going to talk right now mostly about AWS because you saw my day job is on AWS, but other providers, they have very similar ones. So I'm going to use S3 for set storage. I'm going to use IAM for manage access rights. I'm going to use API gateway for creating URLs. And guys, I'm really sorry for those of you who knows AWS, because right now I simplify things a lot. I'm not lying, not lying, but people who know AWS, they may say that it's not quite correct. That's just simple, right? I want to have things casual, let's keep it like this. It's not like. And with this, let's move on. I will use CloudFormation for deployment and AWS Lambda later about it. And as I said, it's really, really important for you, for those of you who didn't try it yet, just go home and try it. I recommend it. And that's cool thing about it, that's going to be free. So it's free for AWS because it has free tier. That's going to be free for all other providers like Azure, Google Cloud, because they also have free tier. And let's move on. AWS Lambda, what is it? And actually any cloud function, what it is. Like every serverless, like every wireless connection, there is wires. Serverless has servers underneath. So that's how things work. So we do have servers. We do run our function on this server. We run it inside container. And basically all this like whole configuration of a function inside container and server is Lambda or cloud function. And the cool thing about it, why I love it so much, you can't forget about servers, like completely. You don't think about these boxes. So, and what that means, the big thing, that's scaling. So potentially and theoretically, things can scale infinitely. That's not like these people who know it, but at least for a small scale, we can think about it. And let's talk a bit about it. So scaling, how that works. Request comes in, we have a Lambda running. 2 more requests comes in, while our Lambda running, we have 2 more Lambda spin up. We can handle it, no problem, because it's like infinite computation, right? More requests come in, we got lucky, our site is popular, and we have more Lambda serving our site. Terrific and easy, so we're gonna stick with this one. And with this, we're done with exposition and we can go to main story. As I said, that's a demo application. After this thing, you can go to my GitHub and try it out. And right now, I just go briefly over the code, so you're going to be familiar with it, and you can play with it even more. First of all, that's how the application is going to look like. That's extremely simple. That's a search which uses YouTube API underneath. You put some words, it will return some videos and render it. How it works with some diagrams, all right? I'm a solution architect, I like to draw diagrams. I'm a C user, I go to a website, and then my browser will get somewhere and ask for this website. We don't have service, so that's why our browser will go to API gateway. And API gateway is already this cloud thing. API gateway will trigger Lambda. Lambda will render our page, return it back. It will return back to the browser, renders in there, and then browser realizes that it doesn't have some static assets. What it does, it goes to the S3 bucket. As I said, we're going to use it for storage our assets, get some bundle.js, CSS, fonts, images, whatever you put in there, and then it can render our site. Browser happy, user happy, we're done. So that's basically server-side rendering. I guess a lot of you is very familiar with it. So let's move on. And if you go to my GitHub, you will see this project structure. I said we're going to do code review, all right? So that's going to be some code. That looks like this. There is a lot of code, but don't be afraid. I used a lot of auto-generation. I used Facebook generate React application. I used serverless, which is framework for deployment lambdas, to generate some code for Lambda for me. So that's why I'm not going to go through all the files, just some very interesting, just something that I changed by myself. That's going to be config, package.json, serverless.yml, and source. We'll start from config. So if we go in there again, a lot of pre-generated. The only thing that matters is Webpack config Lambda. I need to create another Webpack configuration so my application can be compiled and rendered and run on Lambda. What matters in here? Not much. Just render my React and Redux for not target. That's it. Then I will go to package.json. Here I just need a few more scripts. One to run my Lambda locally because I need to test my site locally, and another one to deploy Lambda. That's easy like this. And then we go to serverless.yml. That's a really small one, and serverless is a really great framework. I didn't talk about it a lot because it has really limited time, but check it out. It will generate Lambda to you, it will deploy for you. And the most important thing in here is this line. So it will point to our Lambda function, which is actually a Node.js function, nothing much. We will look into this later. And another one, I will just specify the Webpack config, which is gonna compile my code. Then we're gonna go to source. Inside source, the only folder which matters is Lambda. And inside it, happy you, we have only 2 files. That's gonna be fast. I will start with handler. That's most important one. And if you remember the serverless configuration, that was actually our Lambda. And that's our Lambda function that has only, how many, 5 lines. If I throw away all meaningless lines, it's going to be 3. So that's pretty cool, right? What is interesting in here, I do really want to catch all the exceptions which rise in my Lambda, because I don't want to show something crappy to user. I want to process it right. And the second one, when it writes the exception and we don't process it right, our Lambda is going to run a little bit longer, like 3 times longer. You don't find it in the spec. That's something that I just tested. So you really want to process it. And another one, create response one. This one just a wrapper which adds status codes and headers to my HTML string, which just render it right inside the browser. And then we go to render function. That's a magical one which comes from the renderer. So let's go and look into this one. And here's the trick. I'm not going to show the whole code of renderer, because what is going on in here, first of all, it renders isomorphic application. Is there people who know how isomorphic applications work? Oh, hi. 3 of you, yeah. 5, maybe 6. I didn't see everybody. But yeah, that's server-side rendering. That's quite complicated. That's whole another topic. I'm not going to talk about it. It requires a lot. So I just did a brief Googling for you. You can do it by yourself and find all these pretty tutorials and look through these. Honestly, that's worth looking into. So I just skip it and just tell that main part of my renderer.js is rendering isomorphic application, everything that I need to do with it. Then it comes to error handling. That I said, it's really important to catch the errors. What I did in this one, I used promises, just because naturally I do some AJAX request, it will return promises, so I use promises to catch it and then do something like process it. And then the another one, we will have 2 environments, which is really differs one from each other. One is local environment, the another one is AWS. And I want to have my files on local run from localhost, on AWS run from S3. So how I can do this? Of course, we need to create the variable, and then we will look into the environment variable as well, how I can pass it. Again, serverless.yml helps me a lot with this. I just pass the environment, it will automatically apply to Lambda. And bingo. So the hard part, or congratulations, you got everything working, you got your Lambda, which gonna render your website. You don't need any service in here, and you will have nice SEO-optimized application running. So let's go to the resolution part. The very first question that people ask usually advantages and disadvantages of doing the Lambdas, doing cloud functions. So what I can tell about it, if you want to know about advantages, I encourage you, go to the provider sites like Azure, like AWS, like Google Cloud. They have so many advantages listed here. It's so nice, sweet, and cheesy there. You will buy it. If you want to know about pitfalls and disadvantages, don't go to these sites, please. It's not the right source. Google it. And the one article I really like, that's again from the serverless. These guys really know what they're talking about, because they did do a lot and they work a lot with the serverless. And they actually did really good overview what's going on with this and when you need to use it and when you don't need to use it. So what else except like server-side rendering you can do with cloud functions? Basically everything. I mean, there is a few limitations in here, but everything. Just a few examples. HTTP services, like REST services, naturally works good with all cloud functions. And again, did you notice this a smooth transition? I'm not talking about Lambdas anymore. I'm talking about all cloud functions from all providers. Then we can go IoT. Alexa works with Lambdas. Chatbot, the same thing. Image video conversion, machine learning, by jobs, and it's only things that fit on my screen, all right? There is much more of this. And if we will ask what else except AWS, there is a lot. Google, of course, has Google Cloud. Azure has some functions, IBM functions. Twilio also has cloud functions if you want to use it. And this wild world of open source. I love it. What they did, like the main and big disadvantage of cloud functions, you get vendor lock, right? Which is not really cool. Open source will release it. So they have a lot of implementations of FAAS, which is function as a service. And here are just some random list. I tried a few of them that works like magic. And you don't have any vendor locks. You can run it on DigitalOcean anywhere you want, going from AWS to Google Cloud, whatever you like. And with this, that's it. Did I make it in time? Thank you. Thank you. Okay, so the question was about performance of Lambda-generated website. And that's actually very, very good. I mean, you can control how much CPU you have, how much memory you have by selecting the size of Lambda you want to run. And there is, I don't know how much details to give in here, but okay, let's go like this. We do have, in my practice, in my project, we have server-side rendering running on servers. We run it on EC2. And we have big issues with scaling because if you get a lot of traffic and you need to spin up another EC2, it's 5 more minutes. With Lambdas, it runs the same fast if you have it already running and spin up another Lambda. In the worst case, it's a few seconds. So no complaints about performance. So there is some issues with performance if you will go, for example, running WebGL, but WebGL performance is like rendering is pretty bad with Node.js at all. You don't want to do it in Node.js. Okay, so the question was about the testing, which is very tricky, like testing, monitoring, and auditing of serverless computation is really painful thing right now. So for testing, we just use regular libraries we use to test Node.js. So that's just Node.js function, we test it like a Node.js. If we want to have some test environments, we use local stack. That's the NPM project which will emulate the AWS environment locally inside Docker, container, Kubernetes, whatever you use. Again, you can argue with me that it's not a real AWS, but it's better than something, than nothing. And yeah, that's it. There is like a lot of things to do in terms of testing and monitoring. So unfortunately, that's not that perfect as I want it to be.
How are meetups in New York compared to meetups in Los Angeles?
Oh, you put me in a very uncomfortable situation. You are all great, all right?
Yeah.